Here we have an Atten Instruments model APS3005S regulated DC power supply. This is a 0 through 30 volt, 0 through 5 amp regulated power supply. This particular unit was purchased through a US reseller through the eBay online auction site for about $80. You can also find this exact model through other OEM distributors such as Computer Circuit Instruments at about the same cost. This is a relatively nice, low-cost unit for the starter or beginner hobby. The only problem with this particular unit happens to be the noise level. The model that I have here will actually engage the fan upon power on, and not when it's needed. As you can tell, when you power it on, the level of sound noise coming out of the fan is really unacceptable for a small laboratory environment. Let's go ahead and crack this open and see if there's anything we can do to help rectify that problem. Okay, upon first look, this is a relatively simple and straightforward power supply design. Standard multi-top transformer in the center. We have display circuitry in the front handling the control mechanism. And we have a single-sided standard PCB with non-surface mount components, through-hole components. And as you can see, we're using a standard 80mm PC fan. I'm assuming this is a 12-volt design. Upon closer inspection of the internals, specifically the power output PCB, I've noticed a location here that's marked for both a T3 and an R0. What's in place in my particular version of this model is a R0 or a 0 ohm resistor, possibly used as just a power jumper. Upon research on another model, I was able to identify that this particular part, the other part that is missing, is a thermistor. It's actually set for 45 degrees Celsius and will close when it hits that temperature. I am assuming that that is the temperature control circuit mechanism for the fan, because other models that do actually contain this do not run the fan unless it's absolutely necessary. Found directly in the back, right above the location previously identified, is a standard PC-based 80mm case fan. This particular unit does not appear to have a high quality fan, hence the amount of noise that's being generated. I think while I'm already in the case, I'll go ahead and swap that out for a much higher quality standard PC-based 12-volt fan. Now, as often the case on a lot of these inexpensive, quickly produced cases and power supplies coming out of China, we actually find that the build quality on the other side of the boards tend not to be the best in the industry. I'll give you a good example here. If you look closely, you'll find a solder bridge that's almost touching the mounting screw for the backplate. And a look at the backplate, you can see lots of scratches and scores. This is clearly a piece of recycled aluminum, probably for another job. Not the highest quality you would expect from such as an Agilent display. But for $80 you can't really complain that much. It does produce the expected output per the specifications. Now the piece that we identified right here with the 0 ohm resistor installed does in fact model back over. And if you look, you can clearly see that this in fact is just simply a jumper from this side to that side. Let's go ahead and desolder this and replace it with our 45 degree centigrade closed thermistor. The part that I'll be using is a KSD01F D 45 degrees Celsius part. There, installed and replaced. Time to reassemble this and see if our work paid off. Looks good. Let's go ahead and power this up. This is still using the stock 80mm fan. With the board fully reinstalled and tested to make sure that we did not break anything else, let's go ahead and replace the stock fan. This is a Runda good quality DC fan, 12 volt, 0.2 amp. Don't really believe this is a good quality fan, just judging by the sound that it produces. Let's go ahead and swap that out. For the replacement fan, I've chosen a Vantech model SF8025L 80mm desktop fan. This is a double ball bearing fan with a lifetime warranty directly from Vantech. The only modifications I did do, I took the sensor wire indicating the RPM of the fan and just wrapped it around the outside of the case. And I did swap the end connector over for the one that was on the stock model. Let's go ahead and install this. Remember, you want the case fan blowing outwards. Go ahead and make the connection. Neatly bundle up the extra wire. I'll go ahead and place the twist tie on it and twist tie it to this power connector here. This way it gets the wire out of the way and doesn't impede the airflow too much. Go ahead and turn it on, make sure that the fan is working.